Okay, ladies and gentlemen, this lesson is Unit 11, Section 5. We are going to learn how to approximate the value of irrational numbers and then locate them on a number line. So, you know already that technology can be very helpful. If you have to estimate the value of the square root of 50, you could just type in the square root of 50 in your calculator and get this value. Okay, this value will definitely remind you that the value is a little over 7. Okay, it's an irrational number. It's going to fit on the number line between the whole numbers 7 and 8. And you could probably place it pretty close to 7 because, of course, 7.07 isn't too far away from 7. The problem is we don't always have technology in our hands. So, what I would like to divert your attention to is this chart that we filled out the other day, or we at least highlighted the other day, the perfect squares. The perfect squares are a great resource because they're pretty easy to remember. And what you could do is, if we're working on the number square root of 50, you come down the list of perfect squares until you get to two numbers that will be on either side of 50. So obviously 50 is really close to the square root of 49. It's a little farther away from 64, but definitely if we had to look in this list to find where 50 would sit, it would sit between 49 and 64. So using that same number line, if instead we were to use our perfect squares, we know the perfect value for the square root of 49 is 7, and the perfect value for the square root of 64 is 8. So in that fact, we could definitely estimate that the square root of 50 sits there. So again, without technology, you actually can estimate these irrational numbers. It's a little bit more difficult, obviously, than just pushing a button, but it is possible. So again, remember how 49 is only 1 away from 50, and let's see, 50 and 64, I think that's 14 units away. So again, this is a reminder that if you're placing your number on the number line, it's going to be a lot closer to the square root of 49 than it is to the square root of 64. And basically, this sentence here is just recapping what we just said. 50 is closer to 49. Square root of 50 is going to be closer to 7 than it is to 8. So it's a little over 7, and of course we could round it to about 7.1 if we really wanted to. Here is how you would use the tens place, look next door, and of course the rounding would happen to be 7.1. So again, feel free to use your perfect squares chart. The next question on your paper, again, you could just use technology and type this in and realize that it occurs between 4 and 5. And we could fill out the number line accordingly. And we know that about 4.7 is what I would round it to. And that means you could place the value right about here on your number line. But if we were to use no technology, and we're looking for 22 among the list of perfect squares, we would have to stop right here. The square root of 16, remember, is 4. Square root of 25 is 5. 22 is in between these two perfect squares, but it is definitely closer to 25. So again, you could probably answer these questions without the technology and button pushing that you see up here. 103, if we go back to our perfect squares chart, we could go all the way down. 100 is right here. That means 103 is just beyond it before we get to 121. So if we wanted to this time just use what we found in our perfect squares chart, we know that the square root of 100, the square root of 121, square root of 103 would fit right about here. Again, it's closer to the square root of 100 than it is to the square root of 121. So we know it's in between 10 and 11. If you want to label these 10, 11, you may as well. And of course, it's helpful to use technology to do our estimation. Down at the bottom, this one, it's best if you just go through using your calculator. Take the square root of 7, or again, take your perfect squares chart, trying to find a value that would be 3 point something, and that value would have to be closest to 4. So if we take the square root of 7, we see it's about 2.6, so we don't want that. Square root of 12 is 3.4, so that's a possibility. I'm going to jot that down. It's about 3.46. But 4.6 is really close to 3.5. I would rather that that value be right in between 3 and 4, so I'm going to try the square root of 15. And that one proves to be a much better fit. 3.87 is the approximate value you get for the square root of 15. So again, 3.87 is definitely going to be closer than the 3.46. And again, using your perfect square chart, you can see that in between 3 and 4 would have to be the 15, because again, 9 is 3 squared, 16 is 4 squared, and so forth. So if you would, flip your paper over on the side. You have 3 practice questions to try. Hit the pause button while you try them, and then go ahead and hit play to check your answers. Okay, now that you've paused and tried the problems, remember you can use your technology, or you could come back to your list of perfect squares. You can find 198. The problem is this list only goes up to 12 times 12, so it's definitely beyond the table that I gave you. But easily we can look at our calculator. Remember how to do your square roots. If we round it off to the nearest tenth, remember how you would round. You want to underline the tenths place, look next door, so 14.1 is your accurate result for this one. This question, I believe you can use your perfect square chart for a couple of these, but again, it's easy enough just to look at your calculator. This one is definitely between 9 and 10 because you end up with a value of about 9.5. Square root of 175 is between 13 and 14, but it's a little bit closer than 13 because you'll see how you only end up with about 13.2. And this one is in between -3 and -4 because of the value you got of -3.46. Now, last question is very interesting because it's asking you to solve a problem about a square table. If you remember about square tables, both sides have to match, and it says the area of that table surface is 65 square feet. So in order to do this one, you have to know something about square roots. Square roots are going to work backwards and find that matching side that is missing. So you will have to calculate the square root of 65. And because it is not a perfect square, you are going to get a decimal value. Your decimal value is 8.062257,748. Remember to always copy down the decimal value on your calculator. And then from there, if they want us to round, you could always round. So it says, what's the approximate length? The approximate length, then we could round this up to about 8.1. And I believe the question was in feet, so that means it's feet when we're all done. That means if this is about 8.1 and this is about 8.1, the area would be about 65. So as always, tape your notes in your notebook. See me with questions.